Moving on to question 2. The periodic table is arranged in periods and groups. Elements in the periodic table show a periodic trend in atomic radius. State and explain the trend in atomic radius from lithium to fluorine. Then we have that little pencil symbol again, and in your answer you should use the appropriate technical terms spelled correctly. So let's have a look at our command words. Again, we've got 2 command words, state and explain. Unlikely to be more than 1 mark for stating something, so again this is a 3-mark question, so probably a couple of marks for the explanation and 1 mark for the statement. In terms of the useful information in the question, well, the first 2 bits are not that helpful. They're just kind of stating something that's fairly obvious. The key thing is in the 3rd sentence there, stating and explain the trend in atomic radius, so that's what we are explaining, and it's across that first period of the periodic table from lithium to fluorine, so that's what we need to focus in on. And in terms of linking back to what we know that atomic radius is the distance from the nucleus to the outer shell electrons, and that distance is determined by the charge of the nucleus. The bigger the charge, the bigger the pull it exerts on those outer electrons. It's also determined by the shielding, the number of electrons between the nucleus and the outer shell electron. So they're the sorts of things that we're going to be talking about, because together they affect the attraction of the nucleus for those outer shell electrons, and therefore how tightly they are held to the nucleus, and therefore the smaller the atomic radius. So first thing we need to do is explain the trend, so keep it as simple as we can. The atomic radius can only go up, go down, or stay the same. In this case it decreases from lithium to fluorine. So a nice simple statement of what that trend does. Now for the explanation. So this is because the nuclear charge increases, but the electrons are all in the same shell, so shielding is the same. Therefore, there is a greater nuclear attraction for the electrons in the outer shell. Key thing with this question and similar questions is that we are clear on the difference between nuclear charge, which is basically the number of protons in the nucleus, and the nuclear attraction, which is the attraction between that nucleus and the outer shell electrons, which does depend on the charge, but it also depends on the shielding, because the inner electrons will shield those outer electrons from the positive charge in the nucleus. So you do have to mention both to get all 3 marks.